Hello friends, myself Mukit Patel, Department of Mathematics. Today I am here to introduce to you a very important topic of mathematics which is called conic sections. So let us begin. Introduction to conic sections. One has to understand what is conic. Conics is nothing but different sections of a cone. To understand conic, we need to understand the basic concept of a cone. How is a cone generated? So for this, if I have a line L, a straight line and a fixed line L, to this, if I take another line M, intersecting it at a fixed point and inclined at an angle theta, if you notice, this line L is fixed, this line M is another intersecting line which is intersecting it at a point, a fixed point, and inclined at an angle theta. Now to this, suppose if I rotate M in such a way that L is fixed and theta remains constant. That means I'll be rotating line M around line L, keeping theta fixed. Then what do I get? What will be the surface generated? Yes, this will be the surface, or this will be the structure generated. This point, fixed point, is called the vertex. The line L which was fixed is called the axis, and the rotating line is called the generator. These two are called naps. So we get two naps. Basically, it is a cone. We get double right circular cone. I hope this concept is clear so far. Now coming back to the main topic, once we have understood what is a cone, now the next phase is to understand what are conics or what are conic sections. As I told you, conics are nothing but different sections of a cone. Fine. If I take a plane and if I happen to intersect the cone, these cones or these two naps in different angles or in different directions, the sections which I will get will be nothing but conic sections. So here I present the next slide. A conic section is a curve formed by the intersection of a plane and a double cone. This is the definition of conic section. A conic section is a curve formed by the intersection of a plane and a double cone. Now look very carefully, one by one. The three are nothing but double cone. But what have I done? I have taken the plane with different sections. I have taken the plane and I have intersected the cone at different positions. For instance, if you take the plane or if you happen to intersect the plane in such a manner that it remains parallel to the generator, As you remember, this was the generator. Now this is the section, or this is the plane. I have intersected it in such a manner that the plane is parallel to the generator. Now what figure I am getting? This is the shape which I will get after intersecting it, and that is nothing but called parabola. So if the plane is parallel to the generator, I get a parabola. Getting it? Second thing, if I happen to intersect the plane in such a manner that it is perpendicular to the axis, line L is, the plane is perpendicular to line L, that is the axis. In that case, what figure do I get? I get a circle. If the plane is parallel to the generator, I get parabola. If the plane is perpendicular to the axis, I get a circle. Getting it? Now, if the plane is parallel to the axis, in the parabola, the plane was parallel to the generator. Now, what is happening is, what kind of section I am taking? I am intersecting the plane just parallel to the axis. So what shape or what figure do I get? I get a hyperbola. And if I happen to intersect it to the axis in such a manner that the angle is greater than theta. At what angle it is inclined? It is inclined at an angle greater than theta. Then what section do I get? I get an ellipse. So 4 different sections: parabola, circle, hyperbola and ellipse. All these 4 sections are nothing but different sections formed by a plane and a double cone. I am just interchanging the positions of the plane with respect to the cone, and I am getting 4 different sections. Okay. Next, a bit history of conic section. Conic section is one of the oldest math subjects studied. I don't think many of you all might be knowing this. The conics was discovered by the Greek mathematician Menachmus in 327 to 325 325 to 375 BC. Menachmus' intelligence was highly regarded, and he tutored whom? The Alexander Great. Okay, so again I have given you a replica of the 3 conditions. This is the ellipse, this is the hyperbola, and this is the parabola. Okay, the next slide. This is the 3-dimensional structure derived from a single cone. Previously, I had given you the figure related with double cone. Here, this is for a single cone. If the plane is perpendicular to the axis, I get a circle. If the plane is inclined at a greater angle with the axis greater than theta, I get an ellipse. If the plane is parallel to the generator, then I get hyperbola. If the plane is parallel to the axis, I get a hyperbola. Okay, the next slide. So again, what was parabola? Parabola is nothing but a section which is derived by intersecting the plane parallel to the generator. So this is the section which I get. Hyperbola, again the same. It was nothing but a section of the plane. If I happen to intersect plane parallel to the axis, I get hyperbola. So these were the four different structures or sections of a cone. Now the entire theory is very vast. As I have given you the heading, it was just an introduction. So I'll just brief you what all things are there in this particular chapter. The first to come up with is circle. The definition of circle, as you know, it is set of all points that are at the same distance from the center. The standard equation of the circle is x square plus y square equals to r square. Standard means the center of the circle is at the origin and the radius is r. If you happen to take these two conditions, that means the center is at the origin and the radius is r, you get the equation of the circle as x square plus y square equals to r square. Now in this, again, the chapter is very vast. You have different forms of circle as well, namely general circle, then circle passing through the origin, circle touching the x-axis, circle touching the y-axis, so on and so forth. So to be very frank, this chapter again isn't too much of details. Then you have tangent, equation of tangent to the circle, equation of normal to the circle, so on and so forth. Definitely all this will be taken up in my next video, where I'll be discussing each and every section of the cone in detail. Okay, next was an ellipse. So this is the structure which we had got, if you remember. Now the standard equation of the ellipse is given by x square upon a square plus y square upon b square equals to 1. Now you might be wondering, what is a square and b square? A is the distance from the point, this point to this point. This is called, this line or this length is called the major axis, and this length is called the minor axis. The length of the major axis is denoted by 2a. From that we have got a square, and the minor axis is 2b, which is nothing but, from this we have got b square. Correct? Again, don't worry, everything will be taught in detail, and everything, minute details, will be covered up in my next video under different headings. For example, I'll give you a separate video on circle, I'll give you a separate video on ellipse, parabola and hyperbola. So please stay in touch and keep watching. So to continue, next is nothing but a parabola. The standard equations are x square equals to 4by and y square equals to 4ax. Y square equals to 4ax is this. This is the graph which we get, and x square equals to 4by is this. So we have two forms of parabola which I have mentioned here as standard equation, but there are four forms of parabola which I haven't mentioned here because of the heading, which I had to mention it because I didn't mention all the four forms, just because I'm giving you the introduction here. Okay, next, again, this was the last condition which we had discussed, that is hyperbola. Again, the standard equations are x square upon a square minus y square upon b square equals to 1, and this is the graph which we get. Okay, this is the standard hyperbola and this is the inverted hyperbola. Inverted hyperbola, the equation is y square upon a square minus x square upon b square equals to 1. If you notice carefully the transition, you will come to know the denominators are interchanging as well as the sign. Because of that, this is called inverted hyperbola. Okay. So thanks for watching. If at all you like the video, please give it a thumbs up and don't forget to share and comment. Thank you.